A 5 kilogram block on a 37-degree incline has a mu sub k, so a coefficient of kinetic friction that's equal to 0.3. What is its acceleration down the plane? So let's draw this situation. It's a similar situation to before, except now friction is involved. We have this block. We know it's accelerating down the plane, right? And we know that it has this component of gravity, which is mg cosine of theta. We have the normal force, which is equal and opposite to mg cosine of theta. And then we have this component of gravity, which is actually pulling it down, mg sine of theta. And then we also know that there's now a frictional force, a kinetic frictional force, which is going to be mu sub k times n, right? So what is the net acceleration? Well, we know that there is a net force, right? It's the sum of forces in the direction that's basically parallel to the surface, right? Which is going to be mg sine of theta, right? And we know it's sliding downwards, so we know mg sine of theta will be bigger, right? Minus then the frictional force, which is mu sub k times n. And of course, this whole thing, because F is equal to ma, is also m times a. And we're trying to find that net acceleration, a. So that's equal to mg sine of theta minus that mu sub k multiplied by n. And n is simply equal and opposite to mg cosine of theta. So that's mg cosine of theta. So notice that the masses will all cancel out. So it's going to be a. Okay. And then that's going to be equal to g sine of theta minus mu sub k g cosine of theta. Right, so now let's actually plug in the value. So g is going to be 10. Sine of theta here, the theta is 37 degrees, but fortunately they actually give us what sine of 37 is. It's 0.6, so we'll plug that in. That's 6 over 10. Minus then mu sub k, which they say is 0.3, so that's going to be 3 over 10. Okay, multiplied by g again, so 10. Multiplied by cosine of 37, which is 0.8, which is 8 over 10. Right, so this is going to be equal, well, the 10s here cancel, that's going to be 6. The 10s here cancel, so that's going to be 3 times 8, which is 24. Divided by 10. 24 divided by 10. 24 divided by 10 is 2.4. So this is 6 minus 2.4, which is going to be 3.6 meters per second squared. And that is the net acceleration, of course, going this way down the plane. So B is the correct answer.